Hello everyone. In this example, we are going to look at the equilibrium cooling calculation for AZ31 alloy. Equilibrium cooling calculation is synonym with very slow cooling. So to perform equilibrium calculation, we are again going into the equilib module of the fact sage. So let's click on it. And as we have seen in the shell cooling calculation, whenever you open an equilib window, it will always ask whether to load the last system or not. Since we are going to go for the fresh calculation, we are going to select no. And this time we are going to select for the keep database and search option. This is just to show you that even if you select yes, you can just go back to data search on the top toolbar and click your database. So since our alloy is AZ31, we are going to keep the FTLite database and click OK. Now it's time to enter our alloy composition. So the first one is aluminum, which is 3%. We have zinc, which is 1, so it will remain 1. We have manganese, which is 0.3. And finally we have magnesium, which is the balance. To get the balance, we type question mark 100, so it will give us the balance out of 100. After this, we will click on the next button and wait for the phase selection window to appear. Here we are going to select all the solutions and all the solids. So solids will form the secondary phase particles, and solutions, since we don't know completely the chemistry of our alloy, we can select all the solution to see what phases are actually forming. Now to perform the equilibrium cooling calculation, go to the liquid phase, right click on the I section here. It will open a sub menu. Now in the sub menu, you have to go to the L option, the cooling calculation option, and select it. When you select the L option, it will ask you for one of the three options here. Either you can say that okay, it's the normal equilibrium calculation, is it a shell cooling calculation, or it's the equilibrium cooling calculation. So since we are doing the equilibrium cooling calculation, we are going to select equilibrium cooling, and let's just say okay. Now here, after selecting equilibrium cooling, we have to specify the cooling steps. Cooling steps is just at what temperature step the fact sage is going to do the calculation for the equilibrium cooling. So here we have selected 25, we can select 10. And here now we have to specify the starting temperature from where the cooling should begin. So we are just going to select, let's just say 700 degrees Celsius. And after selecting this, we are going to hit calculate. We have an error. So what does this error say is that you cannot have an ordered phase in the cooling calculation. So we need to remove this phase. So let's just remove this, and this is here. Yep. So after removing this solution, we can just click calculate again, and let's wait for the result. In the result window, you can see that we have multiple tabs. The first tab which will open is the summary tab, which, as the name suggests, give you the summary of the calculation. Here it will show you the initial composition of the alloy, this one completely, and then it will show you the solids which are formed one by one. So constituent 1 is the first solid which precipitates out of the liquid. So this one is SCPA3, and constituent 2 is the second solid which precipitate out from the liquid. And then the summary of reaction will show you all the delta H of the reaction and at what temperature these precipitations happen. And then this section here will show you the chemical composition of your each constituent. So constituent 1 from the top we can see it was SCP-A3, but in SCP-A3 what is the mole fraction of each element and the total amount which was precipitated out is given here. Similarly, what is the chemical composition of our constituent 2? The next tab is the transitions tab. It will show you all the transitions happened during the solidification here. So the starting temperature was 700 degrees Celsius, and at that starting temperature it will show you the composition of the liquid. Then the first transition temperature, which was 629.71 degrees Celsius, and again the liquid composition at that temperature. Similarly, it will show you all the transition temperatures here, and the final transition and the final disappearance of liquid, which is 554.68 degrees Celsius, and the final composition of all the phases. Next, we have multiple tabs which will show the equilibrium calculation at those temperature. So if we go to, let's say, 560 degrees Celsius, so it will show the equilibrium calculation at 560 degrees Celsius, but we only have till 554.68. so if we have more calculation, so I think here our final disappearance temperature was 554.68, which is the last tab here. So there is no pages, but if we have more calculation than the calculation shown here, it will be shown in this menu, the show pages menu, and you can go to different pages to look at all the results. Now, to compile all this set of results into the graph, we will go to the output, go to plot, click on plot results. It will compile the results, and now we need to select our axis and the species we want to plot. Let's first select the axis. So the y-axis we will plot the gram, because we want to know the amount of the phases during the solidification, and on the x-axis we will plot the temperature. So let's just refresh it. So as you can see, when you refresh it, it automatically adjusts the axis according to the calculation, and press OK. After that, we have to select the species. So to select the species, click on select, and to select all the stable species which have been formed during the calculation, you go to the select button here and select all stable phases. If you want to select some particular phases, you can select from here. And if you want to know how many stable phases have been formed, you can just select all the stable phases and it will show you the number of species selected. So there's only 4 species which have been formed during this calculation. So let's just press OK and let's press plot. Now you can see this is the equilibrium plot of our equilibrium cooling calculation. Here it may seem that we only have 2 phases, but if you pay attention, we have some squished up phases forming here. So we want to stretch our y-axis. To do that, we are going to double click on the y-axis. Now you can see that we have x-axis, we have y-axis, and we can just simply stretch it out. So let's just see, we have 5, so let's go to 1 or maybe 2 and increment as 0.5 and this one as 0.1. Let's press OK, and here we have one extra phase which was forming, and we just zoomed out our view. And to revert back to the old view, we can just double click on the y-axis again and adjust your view here. So let's just readjust everything, and yep, we have came back to our previous plot. So thank you for listening. This is for and these are the steps for performing equilibrium calculation for AZ31 alloy. Thank you.